Hello, everybody. Welcome back to the third and final of today's lectures. Congratulations for making it this far. The first question, or the last question, sorry. What are energy levels, sublevels, and orbitals? This is a great question. What are all these things that we are dealing with? We need to figure it out. And so the vocabulary for this last section are principal quantum number, principal energy level, and energy sublevel. Sounds good. Let's go. So when looking at a hydrogen atom or hydrogen orbitals, the principal quantum number, or N, indicates the relative size and energy of an atomic orbital. Okay. N specifies the atom's major energy levels, which are called the principal energy levels. Okay, and so if down here is the center of your nucleus, then you have your energy level 1, principal energy level 1, which has 1 sublevel, and you have principal energy level 2, which has 2 sublevels, and principal energy level 3 has 3 sublevels, and 4 has 4. Okay, and each sublevel we're going to discover is a type of orbital. Each energy sublevel relates to a pattern of electron motion called orbitals, which have very distinct and different shapes. Okay, and so you have s orbitals, which are basically spheres of different expanding size. You have p orbitals, which are said to have what's called a dumbbell shape, or hourglass shape maybe. And there's 3 of those, whereas there's only 1 s orbital per energy level. And then you have d orbitals, which look like, I don't know, cross dumbbells on each plane, and then there's one with this weird kind of circle shape in the middle. And then you also have f orbitals, and we'll look at those a little bit later. And so when you're looking at your energy levels, this table is a good one to look at here. So you have your principal quantum number n, and it's 1, 2, 3, 4, right? And your first quantum number has a single sublevel, a single orbital of s orbital, and the number of orbitals is 1, and the total number of orbitals in that energy level is 1. Okay, you go out to the next energy level, and again, it's an s, but it also has a p orbital, s and p. The total number of orbitals, there's 1 orbital in the s orbital, there's 3 orbitals in the p orbital, and again, we'll talk about that more, and the total number of orbitals in the energy level is 4. Okay, you go out to the third one, and you have an s, a p, and a d. 1 orbital in that s, 3 orbitals in that p, 5 in that d, for a total of 9 orbitals. And then you finally go out to a 4th energy level. It has an s, p, d, and f. Your s, again, only has 1 orbital, p has 3, d has 5, and f has 7, for a total of 16 different orbitals. And again, we're going to talk a lot more about all of this, but for now, this is great information to know. Now, the periodic table relates to these orbitals, and we'll talk about this a lot more in the next chapter too, but elements in your first 2 groups have electrons in their outermost electrons in the s orbital. Elements in what's called the p block on the other side here of the gap have their outermost electrons in the p orbital. And then you can find electrons in the d and f orbitals as well, but their energy is always lower than the s and the p orbital, And so they're not the outermost electrons called valence electrons, which we'll talk about more later. I just wanted to introduce you to this diagram now. So, what are energy levels, sublevels, and orbitals? Well, these are the patterns of electron motion around the nucleus of an atom. And they become more energetic the further out from the atom you go, and they have wave-like patterns of motion called orbitals. And so, what is quantum theory, or what is the quantum mechanical model of the atom? It is an atom with electrons that move like waves that get further and further out with more and more energy as they get further away. So, hopefully this makes sense. Don't worry if you don't understand it all perfectly. We still have 2 more units in this chapter to get to, and we definitely will. But thank you so much for listening, and that's all for me for today. Thanks.